we've done the basics of note names, we can carry on to refine this concept a little bit more. So, if we recall, basically note names just works on a grid that goes with time going in that direction and pitch going in that direction. So, if for example this note is A, then this will be B, C, D, E, F, G, and then A over there. And then the next step of complication is just to have a clef that shows us which note is actually which note. So this one tells us that this note over here is our G, which means that this is A, B, C, D, E, F, G again, and then A over there. So that's the basics of it. But now we're going to make life a little bit more complicated, because when you have the notes going up in pitch like that, it doesn't correspond evenly. So, for example, if we have a look here, we said that this note was an A and that note was a B. So A to B is a certain distance apart, but B to C, or B to C, is a smaller distance apart than A to B is. So the reason for this is because the note names were devised before there was a real need to be able to move freely through the keys. Now, I haven't actually introduced the concept of keys yet. So this is what this video is going to be about. The whole idea of keys and key signatures. So, to get us started, I'm just going to draw a little key over here that will unlock all of this for us. So there's lots of different keys. There's the key signature, and this is a keyboard. So anyway, the basic idea, and when I say this is a keyboard, it's just a rough approximation to a keyboard. So, but if you match this up to a piano keyboard, you'll see that it matches up. And then there, and there, and I think I need a little bit of extra space over here. So put that over there, and there again. So this is going to be our key for the distances between notes. Now, I'll admit this isn't the prettiest, but that's the basic idea. So what happens is, just like we had the notes going up the pitch like here, now we're going to have the notes spread out like here. So this is going to be note C, this is going to be D, E, F, G, A, B, and C again. So what's being illustrated here is that in between the notes C and D and E, actually let me do this in a different color, in between C and D and E, there's another extra note, but there's no note in between E and F, and again between F and G and A and B, there's an extra note, but no extra note between B and C. So the interval here, when you have that extra note in between, that's called a whole tone. So I'll just put that WT for whole tone. So each one of these are whole tones. And the interval here, I'll make it with a little arrow, is a semitone. So the principle is that every time you go from one note to the next note, you get a semitone. Semitone. And semitone. And semitone. So that's the basic principle of how it works. You get whole tones and semitones. So now we just want to come up with a name for these things in between. Now, there's two ways of naming it. We can either say that this note over here is a little bit higher than C. So or we could say that it's a little bit lower than D. So the notation we have for that, when it's a little bit higher than C, we say C sharp. And when it's a little lower than D, it's D flat. So these sharp and flat sounds change the note by a semitone. And so C sharp will be there. So in other words, the note C sharp is the same as the note D flat. And this is called enharmonic equivalence, where you have the two names for the same note. Now, technically, these two things are not the same note. But for our purposes now, we're going to ignore all of the complications that come around this. And we're just going to say that C sharp and D flat is the same note. On a piano keyboard, that will always be the case in any case. So you don't have to worry about anything more involved than that. So bearing this in mind now, this means that a D sharp will be the same as an E flat, and an F sharp will be the same as a G flat. So let's list these out nicely. So we have a nice full list here. So in other words, a D sharp will be the same as an E flat, and F sharp will be the same as a G flat, a G sharp will be the same as an A flat, and an A sharp will be the same as a sharp will be the same as a B flat. So each time it works like that. So, what about an E sharp? So, again, we just work with the same principle. An E sharp will be there. So E sharp is the same as F. And F flat is the same as E. And again, the same thing applies here. B sharp is the same as C, and C flat is the same as B. So that's the basic idea. It's fairly straightforward, and all that one actually has to remember is that the ones without the extra note in the middle are E to F and B to C. So those ones don't have your extra semitone in the middle. When there is something in the middle between the two notes, then it's a whole tone between them. When there's nothing in the middle, then it's a semitone in between them. So that's the basic principle. This might not look exactly like a piano keyboard, but if I just do this, then it might be a little bit easier to see. So there's your normal keyboard layout, just like that. And then of course you would have the keys going in between there. So for people who play keyboard instruments, they should have a picture of what a keyboard looks like in their mind already. But for people who play other instruments, this is just something that you just have to learn. That between E and F and between B and C, there's no extra note. So there's a little bit extra complication here, but this might just help just illustrate the concept a little further. Firstly, if you have a C sharp and you want to turn it into this note, you have to flatten that, so you have to take that sharp away. Now, in very old notation, they used to actually just write it as a C flat, which meant flatten the sharp. But one can see that that will cause quite a lot of confusion in practice, which it did. And so a new symbol was invented, which is the natural sign. And so if you write an E, you could also write E natural. And so if you had an E flat at some point in your piece and you want to write not E flat, you just write the natural sign over there. So that's the one. And the other one is that you can now go and do C double sharp. Now C double sharp will be C, well, if I do it this way, C sharp and then double sharp. So that puts us at the D. And by the same token, D double flat will go 1, 2. So D double flat, which we write like that, is a C. And again, to illustrate the principle, if we go E double sharp, so we have E sharp, E double sharp. So E double sharp is the same as F sharp. And again, by the same principle, F double flat, 1 flat, 2 flats, gives us a, so F double flat gives us an E flat. So, you can work out how it would be for the rest. C double flat will give us a B flat, and B double sharp will give us, here's your B over here, so you go 1, 2, will give us a C sharp. So in principle, it's fairly straightforward. In practice, you very rarely use these until much later. It's not extremely rare though. It does happen. Yes, but that's basically how the sharps and flats come about. In the next video, we'll use this principle to help us just work out the keys and to come up with the key signatures. But that just extends our basic picture that we had of the pitch being notated up in this direction. So it's a little bit more complicated than just being a straight matrix like that.